So we've talked a lot about how you encode data and trying to translate between Excel and Python, but I think the real question at this point is how do you actually do anything with this? So if I close out the Excel side here and bring this into... So if I close Excel and just focus on this, I think the next step is to talk about how you actually write a longer running program and what that looks like. So we'll stick with this sort of data input for now and work with this. So say, for example, that you want to loop over every child ID and like check something to do with the child IDs. Maybe you want to check if the number is bigger or smaller than 100. So to do that, you're going to need to understand two concepts. You need to understand an if statement, which is a way of checking if something is true. And then you need to understand loops and how to loop over values in a list, or even in general. So to begin with, let's think about writing this check. So if you have a child ID, we'll leave this data up here, but we won't use it for the moment. So if you have a child ID equal to 300, let's print out whether this child ID is greater than 100. And if I run this, as you might expect, you see the output true, which tells me that this is, in fact, greater than 100. So the way of doing something if the child ID is greater than 100 is you rewrite the statement as if child ID greater than 100, and then with a colon. Then most editors will do this automatically, but all the code that happens afterwards is then indented out. You can use 2 spaces or 4 spaces. It's up to you. I think I would just use whatever is the default. So in this editor, it's 2. And within here, you write the code that you want to execute if it is greater than 100. So let's print out it's greater than 100. Else, print out it's less than 100. So again, the format of this statement is you can say if, and then the condition that needs to be true, if you want it to be true, and then an optional else. This is also not needed, but if you want code that only executes if this isn't true, then you would write the else. So if I run this now with a child ID equal to 300, what do you think will happen? I run it now, and we get it's greater than 100. And as you might expect, if I then put this to 99, it's less than 100. What about if I put it to 100? Pause for a second and think about this. We actually get it's less than 100 again. So, I mean, the option, this is because we're doing a strictly greater than. You could instead write greater than or equal to, and if I run it again, it will say it's greater than 100. So let's say that we want to check this for all the child IDs in this list. So one way we could do that would be to sort of copy each of these individually and copy out this code, but the whole point of code is to automate all that stuff and make it easier. So let's take out this list of child IDs. So as you remember from the last video, to do that, we'll just index on child ID, which will return this value, the list. Then what we can do is, what we essentially want to do is for every child ID in the child data, so in this list of child IDs, we want to check if it's greater than 100. So the way that you write that in Python is you say for the child ID in child IDs. And then all of this now needs to get tabbed out again. So you tab this out. So I selected everything there and hit tab to make sure this is on an inner indentation level, so that this code is running within that loop. So let's then print out this child ID when the loop starts running. And we can even print some information like checking child ID. Then if it's greater than 100, we'll see if it's greater than 100, and if it's less than 100, we'll see it's less than 100. So this is definitely going to be a bit of a harder one, but if you're able to figure out what happens when I hit run now, then you're starting to get the idea of these loops. And as you can see here, so we see each of these are printed in turn, checking this, and that's greater than 100, checking this, it's greater than 100, and then checking 27, and it's less than 100. And I think this sort of construct is something that you'll see quite often. So here we've looped over lists, and I think this is a kind of the simplest way to think about. But lots of objects let you kind of do this for x in that object kind of method. So, for example, this dictionary object you can also loop over. So, if I loop over child data, what I will get is I will get the key name. So that's going to be either child ID and then legal status. So obviously this check doesn't make sense if for the legal status code. So what we can do here is we can say, okay, well, if the key name equals child ID, then we will do our loop again over that list, and then our code inside stays the same. So now if I run this, I've introduced another loop, but I haven't changed the output to the code at all. And if I run this again, you should see that it's the same thing here, because what happens is we loop over both the keys in this data, we check if it's equal to child ID. If it is, we then run the code that we'd already written. So that's why the output's the same. Then when it goes around again for the second loop of this for loop, the column name is legal status. So we don't do anything with the legal status information at this time. However, we can then expand this further to do something with that. So we can check here if the key name is equal to legal status. Then we can check, for example, is the length of each of these legal status codes 2? Obviously, we can see that it is, but you can imagine if you had 1,000 points of data and you're trying to do more validation, it's good to make this kind of programmatic check. So then you can pull out all your legal statuses from the data, and then check for legal status in legal statuses. If print legal status, and let's print the length. So now we'll get a output which prints each of the legal statuses and their length. So before we jump into the last concept that we're going to talk about today, I want to talk a little bit more about indentation. So by indentation, what I mean are these sort of spaces that are between the different blocks of code. And in Python, indentation is used for indicating sort of locally scoped blocks of code. So what this means is that to find out what's under this if statement, it's everything that's indented one level in under that if statement. Same for this for loop. So what code is going to get looped? It's everything that's indented one level in. So if I add a print here, and print in the loop, this will print twice because there's 2 key names in a child data. So we get an in the loop print at the end of the first key name and in the loop print at the end of the next key name. However, if I indent this one layer out, it will then not be in the loop at all and will only print at the end of the script. This is a kind of important concept to wrap your head around because you can end up in strange situations. So if you end up, say, indenting weirdly, so for example, you do something like this, and you try and run the code, but that's now indented 2 indents, you'll get an indentation error. where what it's saying here is now it can't figure out what to do with this code because it doesn't seem to match the indentation level to 4, and it doesn't seem to unindent to indicate that it's come out of that 4. So again, if you just put this back in its original level, it will then run fine. So that concept being covered, we're now going to jump into the last concept that I want to talk about today, and it's probably an important one, which is functions. So the sort of idea behind this is that obviously already we're starting to have written a longer piece of code here, which is doing a few different things. So it's sort of looping over our big bit of data and then doing a specific bit of work on the child ID and then a separate specific bit of work on the legal status. And when you're writing your code, you can imagine that you might, in other cases, want to also check if the child ID is greater than 100, or you might also want to check if what the length of the legal status is. So a way that you can do this is to kind of abstract those notions away from where they're written in the code, and instead just write a function which will return the information that you need or print out the information that you need. So say, for example, for the child ID, if I want to create a function, you use the def keyword, which tells Python that you're about to give a function name and describe how the function works. And we'll call this check child ID greater than 100. And this is then followed by brackets, which can either be empty if the function takes no arguments, but in this case we want to pass a child ID to this function so that I can check it. And then you finish that statement with a colon. And again, you're now in a lower indentation level, so everything within this indentation level will be about this function. So what we'll do is we'll take this code here as a start. So I'll leave in that print statement, but I think this is the part that's kind of key to being part of the main body of this function. And you can see pasting it in, the indentation's kind of gotten a bit messed up because it's pasted at the same level. So what I'll do is bring this back to that first level of indentation, and then the last sort of piece to be aware of in these functions is what's called a return statement. So basically, this uses the return keyword. So say here, what you might want to do is not only print things out for this function, but also use the calculation this function has made down the road. So say here, you might want to return true because it is greater than 100. And here, you might want to return false. So now, what will happen is when you call this function with a child ID, it will print out it's greater than 100 and return true if it's greater than 100, and else it will print out it's less than 100 and return false. So now we can take this body of code here and just replace this with a call to this function. And we can check as well that the return value is what we expected. So we can say print return value returned. So here, I'm calling this function. I'm passing this child ID as the argument. Then on the call, this child ID gets translated into this variable here. And I mean, these two variables don't have to be the same. I mean, this could be x as long as as it matches within the function. But for now, I'll keep it the same because I think it's a better description of the function. And then it'll return either true or false, and then that'll get assigned to returned, and then a return value will get printed. Functions don't have to return anything. If you don't write any return statements, a function will return none by default. But often that's what you want to do. And say in our error checking code, which we'll be looking at later on, the way that'll work will be that you're writing functions which return the locations that the errors are at. So this concept is fairly important to understand. So now, if we run this code, you can see, again, stepping through. So we check the first child ID. We see the print is greater than 100, so it's now in this function. That returns true, which gets assigned to returned here, and then gets printed out, return value true. And again, you can follow this through for the others and see that return value is being sent back. And again, maybe you want to write a function that doesn't actually print anything and just gets length of legal status. For example, we'll call this actually get length of legal status. And that is just going to return the length of legal status. I mean, here you've actually done something which initially looks like a lengthening, because now when I go to replace this function, I'm now calling my own function get length of legal status rather than the built-in function len, which returns the length. However, what this allows you to do is to kind of abstract your notion of what a length of legal status means. Maybe you'll decide that actually there's certain legal statuses that shouldn't just be the length of the string of the legal status, but you want to add some extra features. And now you can do that without having to go back here and figure out how to change it in this code. So what these functions let you do is kind of abstract different concepts that are important to you and think about those separately, which is a really key and important part of programming. So now that we've sort of covered the basics of functions, and this is already getting relatively close to the sort of code that you might write for validation. I think in the next set of videos we'll talk more about some of the other tools that we will be using to make our job a bit easier, so we're not having to write so much code to check each of the validation rules. And then I'll introduce some wider parts of the Python ecosystem there as well.